Test. Okay, this is the Physics 101 Exam 1 from fall of 2010. In number 1 it asks, which answer has the appropriate significant figures for this operation? You're multiplying and dividing numbers, so you keep the lowest number of significant figures. This has the lowest number of sig figs. It just has one significant figure, and so the answer should only have one sig fig, so that answer is A. What is the area of the projection screen in the front of this room? That projection screen is approximately 3 meters by 3 meters. That's about 10 by 10 feet. And so that gives you a rough order of magnitude estimate of 10 square meters. Which of these is a reason that a standard of measurement is not appropriate? Alright, a standard of measurement is not appropriate if the standard changes with time and if it is not available to everyone. Those are reasons that a standard of measurement is not appropriate. It doesn't matter if it's based on some obscure physical constant. You know, we base standards of measurement all the time on obscure physical constants, like the speed of light, for example, which is fairly difficult to measure. And of course, it doesn't matter if it smells bad. So the answer is B. Or excuse me, not B. It's yeah, B. Number 4, is this equation dimensionally correct? Well, x is in meters, a is in meters per second squared, m is in kilograms, and t is in seconds. So this on the left hand side gives us kilogram meter squared per second cubed, and then on the right hand side we have kilograms meters squared per second squared. That's v squared. V is meters per second. A is in meters per second squared, and then V is in meters per second, but that's inverted, so I'm going to write it as S meters seconds over meters. So let's see, this meters cancels out with this one, and this seconds cancels with one of these, and so on the right hand side we're left with kilogram meters squared per second cubed. So it is dimensionally correct. A car accelerates at 10 meters per second squared. What is this acceleration in kilometers per hour squared? So we say 10 meters per second squared. In 1 hour, or excuse me, I'm sorry. In 1 hour, there are 3,600 seconds. We want to square that, and then to convert the meters, in 1 kilometer, there are 10 to the third, or 1,000 meters. This cancels out seconds squared, cancels out meters, and it leaves us with kilometers per hour squared. And if we do this, we get 10 times 3,600 squared divided by 1,000. Get 130,000, 129,600, but with proper sig figs, 130,000 kilometers per hour squared. A house is, okay, number 6, it says that a house is 45 by 32 by 8 foot. What is the volume of the interior of the house in cubic centimeters? Well, first we just want to find out what is the volume in cubic feet. So we say 45 times 32 times 8, and that gives us the volume is 11,520. And that's in cubic feet. And then I want to convert that into cubic centimeters. So in 1 meter there are 3.3 feet. The conversion factor I give you. We have to cube this, but then we need, so that gives it to us in cubic meters. And now we need to convert it into centimeters. In 1 meter there are 100 centimeters. I want to cube that. And if we put it in our calculator, we get 320 million, which is 3.2 times 10 to the 8th cubic centimeters. So that is option C. And this, by the way, is option A. Alright, number 7. Since 1983, the standard meter has been defined in terms of which of the following? It used to be B, the specific alloy bar. It used to be C as well, but now it is D, the distance that light travels in a particular amount of time. You drive 4 miles at 60 miles per hour and another 4 miles at 40 miles per hour. What is your average speed? Well, you travel for a longer time at 40 miles per hour. So that means that your average is going to be less than the average of the two numbers. So the average of 60 plus 40 divided by 2, that's equal to 50. And so the average is less than 50. So that is B. Describe the motion of the particle shown in this graph. We want to look at the slope, and how does the slope change? The slope is initially positive and small, gradually gets bigger and bigger. Alright, so it's increasing positive velocity, and that is B. Alright, this graph represents the motion of a particle. What is the particle's instantaneous velocity at t equal 4 seconds? Alright, you have to be sort of careful with this. You want to draw a tangent line at this point. Draw a tangent line. And then I'm going to find out the slope of that tangent line. The rise, I'm going from -3 to 3, so my rise is 6. And then my run goes from 3 to 5, so that's 3 to 5 is 2. And so my rise over run is 6 over 2. Which is equal to 3. That's my slope, which in this case is an x versus t graph, so that is my instantaneous velocity, 3 meters per second, and that's option E. In the previous graph, what is the average velocity between t equals 0 and t equal 2 seconds? Well, average velocity is equal to delta x over delta t, just x final minus x initial. X final is -4, x initial is -1, over delta t, which is 2 minus 0. These are in meters. This is in seconds. That is -4 plus 1, -3 over 2, or -1.5. So that answer for number 11 is C. You throw a ball into the air and it returns to your hand. Which of these plots best describes the motion? So you throw it up in the air, and initially it has a positive decreasing velocity. Positive decreasing velocity. Alright, this one is negative. This one is negative initially. So we're either looking at B or D. It's positive decreasing. It goes up. It stops right there. So, and these both have V equals 0 at the midpoint. That's when it reaches the top of the trajectory. And then it starts coming down. It has a negative increasing velocity. Alright, so B is the only one that has a negative increasing velocity. This one has a positive increasing velocity, and that's not correct. You drop a ball from a cliff of 110 meters. How long before the ball hits the bottom? I can do this in a couple different ways. I'll say that y naught is equal to 0. That means that my y is minus 110 meters. That means, like, here's my ball. I'm dropping it down here. This is y naught, and it's equal to 0. This is the bottom of the cliff, and it's equal to minus 110 meters. Alright, how long before the ball hits the bottom? Well, I know my acceleration is equal to minus 9.8 meters per second squared, and I know that my initial velocity is equal to 0 because it's initially at rest, and so I just say y is equal to y naught plus v naught t plus 1/2 a t squared. V naught is 0, y naught is 0, so I have minus 110 is equal to 1/2 minus 9.8 t squared. And I multiply both sides by 2, divide both sides by minus 9.8, and take the square root of both sides to get rid of the t squared, and that'll give me the answer. So I have 110 divided by 9.8, the negatives cancel, times 2, square root that, I get 4.7 seconds. T is equal to 4.7 seconds. And let's see, that is option D for number 13. A speeding car is traveling 40 meters per second and is pulled over by a state trooper. The car decelerates at 2 meters per second squared. That's going to be a negative 2 meters per second squared because its velocity is in the positive direction. It's slowing down, so the acceleration is in the opposite direction. What distance does the car travel before it stops? Alright, now I know that v final is equal to 0. Because he's coming to a stop, we first need to find t, and then we can find x. This is really the most difficult problem on the test because it has 2 steps. So I'd say v final equals v naught plus at. 0 is equal to 40 plus minus 2 times t, and then I solve for t. T is equal to 20 seconds. So it requires 20 seconds to stop. Now, I want to find x. So I just say x is equal to x naught plus v naught t. So v naught t plus 1/2 at squared. This is 40 meters per second. That's our v naught. Times 20 seconds plus 1/2 of minus 2, which is our acceleration, times 20 squared. If I put in those numbers, it's 800 minus 20 squared is 400 meters. So x is 400 meters. Travels about a quarter mile before coming to a stop. 400 meters, that is A for number 14. Number 15, what is the instantaneous acceleration at point C? That's at this point. In order to find that, you want to find the slope right here. It's rise over run. The rise is from 2 to 4, so it's 2. The run is from 3 to 4, so it's 1 unit, or 1 second. And so it's just 2 over 1, which is equal to 2. But actually, you know, I like to just look at the graph, and I see that this graph has a negative slope, and so I know it's -2. So the answer would be B. The more rigorous mathematical way is that you would recognize that your rise here is actually -2. But I always find it useful just to look at the graph, just to get a feel for what's going on. So it's actually -2 over 1, which is 2 meters per second squared. You throw a ball upward with an initial speed of 10 meters per second, assuming there's no air resistance. What is its speed? It's equal to 10 meters per second. That was straight from the concept test. Which of these statements about vectors is incorrect? Now, I gave everybody credit for this problem because there's a typo in it. The answer was supposed to be A. Now, you might see this again on the exam, so listen up. The answer was supposed to be A, but A is miswritten. So the vector can have a magnitude greater than one of its components. What it was supposed to say is that a vector's component can have a magnitude greater than the vector, or that the magnitude of a component can be greater than the magnitude of the vector. And that is not true. But in this case, all of these are correct. A, B, C, and D are all correct. And so I didn't count this at all. I gave everybody credit for it. While exploring a cave, a spelunker starts at the entrance and moves the following distance: 62 meters south. I'm going to make my XY component table. 62 meters south, so that's minus 62 meters. 130 meters at an angle of 30 degrees. 130 cosine of 30. That's my X component north of east. And as I drew on the board, that north of east is like this. And 20 meters south. Let's see, this is 130 sine of 30. And then 20 meters south, so it's 0 minus 20. I want to add up my X and Y components. The X component is just 130 cosine of 30, which is 113. And then the other is 130 sine of 30 minus 80 minus 15. Alright, I just want to know the magnitude. So that's easy. I just say square root of 113 squared plus 15 squared. I just drop the negative because you're squaring it. It doesn't really matter. It goes away. It is 114 meters, which is option B for 18. Alright, which of the following figures show vectors A and B? What is the difference A minus B? Well, here's my vector A. My vector minus B looks like this. So this is A minus B. So this is A minus B. The difference A minus B. And that is the same as vector D in number 19. The vector A has components AX and AY. If AX is less than AY, which of these is the possible direction for vector A? I like to draw a picture. This is AX. AX is less than AY. So this is AY. And I want to know what is true about this angle. Can it be 72 degrees above the negative x-axis? No, it has to be above the positive x. Can it be 64? Yes, that's the answer, but let's look at the others. Can it be 43 above the negative x? No, because it's above the positive. Can it be 55 below the positive x? No, that would be in the fourth quadrant. That would be not correct. And 45 degrees above the positive x-axis. It is supposed to be above the positive x-axis, but 45 degrees would imply that AX was equal to AY, because that's an equilateral right triangle. So it has to be B. If vector A has a magnitude of 12 and vector B has a magnitude of 25 meters, which of these is a possible solution? Or you want to look at the maximum and the minimum, just like in the concept test. The maximum that you could have is 12 plus 25. That's equal to 37. And the minimum that you could have is 25 minus 12, which is 13. So it has to be between 13 and 37, so that would be C. 32. Particle begins at the origin and travels 3.4 meters to the right, 2.8 meters, 120 degrees, finally it moves 1.2 meters down. What is the magnitude of the particle's displacement? Alright, this is just like the Spelunker problem. It is 3.4 meters to the right, 3.4. The y component is 0, 2.8 cosine of 120, 2.8 sine of 120, and then 1.2 meters down, minus 1.2. Now I want to add those up, 3.4 plus 2.8 cosine of 120. Let's see, 3.4, 2.8. That gives me 2 for the x component, and 2.8 sine of 120, minus 1.2 gives me 1.2. I'll just do it just like I did before. 2 squared plus 1.2 squared, and that is 2.3, which is D. The accretion luminosity of a protostar is given by this equation, where those things are as they are. Which of these is a possible explanation for low luminosity protostars? If the accretion rate is low, that gives you a low L. If the protostellar mass is low, that gives you a low luminosity. And if the accretion radius is big, that gives you a low luminosity, so the answer is D. Based on this graph, which statement best describes the location of stars in quadrant 4, that's quadrant, that have low, that means they have a low reddening but a large distance. Well, if you remember from class, this is your telescope. Here's your star-forming core. You have stars in the front, you have stars in the back, and then you have stars to the side. Stars to the side and in the front, and stars to the side and in the back. These stars are going to exhibit high reddening, alright, and they're in quadrant 1. These stars have no reddening, and they're in quadrant 3. Then these stars, which are to the side of the core and behind the core, show no reddening, but they have a high distance. So those are quadrant 4, and let's see, more distant but to the side of the star-forming core. That is C for 24. And then 25, this is version B.